So what we're doing today is similar to what we did yesterday, except for one key difference. The bases are not the same. And there's no way that we can write 7 as 2 to a power. Well, we can, because that's actually what we're trying to find, because we're trying to find what power can I put 2 to be able to get it to equal 7. But it's not going to be a whole number. It's going to be a really ugly decimal. But there's a different method that we can use to be able to solve this. And it's going to be using logarithms. Now, when we look at this here, if I take log base 2 of 2 to the x, what do we get? What do we say when the base and the number inside of it are the same? They cancel each other out. So this here, log base 2 of 2 to the x, is just going to be x. But what we do to one side, we have to do to the other. So we have to apply log base 2 to 7, which tells me that x is equal to log base 2 of 7. So John, we just need to find the value of x, because we can plug this into a calculator. Now, if we don't have, because if you have the graphing calculator, we can do math, go down to log base, and type it in, and it would give us and that would be our answer. And there are more decimal places than this here, but we'll leave it at 3. We'll stay at 3, and I think the homework is just going to ask for 3 as well. But that's all we have to do. Now, if you don't have the graphing calculator at hand, we can always do the change of base, which is just taking log of 7 over log of 2, which will give us the exact same thing. So we can do it in either way. Any questions on this here? That's it. So what would we do for this one here? Yeah, we'll apply log base 3 to both sides. Because realistically what we're doing is we move the x out front, and log base 3 of 3 is 1, which just simplifies to x, leaving us with log base 3 of 8 on the other side, and then we just need to simplify this here. And we're going to get 1 point, I think 8 or 9 is, my guess. 8. Wow. It's actually closer than I thought. And the reason I was guessing that is because 3 squared is 9. So whatever number we're looking for is going to be close to 2. Any questions on any of this here? Are you kind of like this so far? Yes? Are you ready for the next one? So what can we do first? We can put both sides, apply log base 7 to both sides, which our log base 7 of 7 is going to simplify to 9x is equal to log base 7 of 15. Now, is log base 7 of 15 a nice number? Is it going to give us a nice number when we plug it in? Well, no, it's going to be an ugly decimal, yes? Is x by itself? Well, no. Personally, I'm going to leave it as log base 7 of 15. Because if I know that this here is going to be an ugly decimal, or it's going to be an ugly number in general, I leave it till the end. Because we're not completely done yet, we still have to do what? Divide both sides by 9 to get x by itself. Which will tell me that x is equal to log base 7 of 15 divided by 9. Now I'm going to plug it in. Because I know I'm waiting because I don't want to have to deal with rounding. Luckily, Big Ideas Math and most of these problems shouldn't have a rounding issue. But once we round more than once or twice, your probability of having an error goes up each time. To where it's going to throw it out because you're 0.001 off. It's not going to accept it. So most likely it's better to wait to round until the very end so your error is smaller. Now, I'm going to go on and show you all this here. I'm drawing on the board. So if you don't actually have a graphing calculator to do the log base, because here it's not that bad. Do log base 7 of 15 over 9. We can type it all in. If we don't have that and we're using common logs, well, we can do log of 15 over log of 7. And I get this here. Now, luckily, the calculator can actually take the entire decimal, or not close to it, as far as we can. But it's not rounding it, it's not approximating, it's getting as close as it can possibly get. And what I can do is I can say divide by 9. Because A and S is just whatever the previous answer is. Hit enter. And this is what you all got for on the graphing calculator. So if you're using the TI-30XS, this is a way that works well for doing these here, especially if we have to do multiple steps. We can break it up and keep using A and S because it's going to keep grabbing it and giving us a more precise answer than if we tried to round it to 3 decimal places and go on from there. So here is equal to 0.154. And that's our answer. Questions on this here? We like this so far? So I want to change this a little bit. Let's do plus. Stormy, give me a number. Let's go 2. Okay. I want to change it to this here. So it is going to change our answer, but as we've seen so far, none of these answers are going to come out nicely, so it really doesn't matter. But we can have other parts attached to this here. So we can have stuff being added or subtracted. It's not really going to change what we're doing. I just cannot apply the log first. Because if I apply the logarithm to here first, well, it's going to trap that 36 with the 5, which won't help us too much. But is there any way that I can kind of get the 36 away from the 5? Yeah. We can subtract it. You have 5, carry the 1. No. It's 5, 4, 7. Yep. I think it should be 275. So now do we have our 5 by itself? The number that has x in the exponent by itself? Well, yes. And now we can actually do the log from here. We won't see it too often where we'll have a number multiplied by 5, like we would have 2 times 5 to the 3x plus 7. We won't see that too often for these here. But with our natural logs e, we can see that because we can have 3e to the negative x and solve it that way. And we'll solve some of those here in a minute. But with this, we won't normally see a number and then a number base to an exponent. So, well, yeah. So we're going to apply log base 5 to both sides. And our log base 5 of 5 is going to simplify to 3x plus 7 is equal to and then what can we do next? We can subtract 7 from both sides. Now these here will cancel, leaving us with 3x is equal to log base 5 of what? We just put it on the end. Because that 275 is inside of the log. Because we're taking the log base 5 of 275. That number is trapped inside the logarithm. Because anything that we do after it is going to be outside. Because realistically, when we applied log base 5 of 275, we put parentheses around it. And for all the ones that we'll have, and I will, if it's on the test, I put parentheses around it. Because I think it's a little too confusing, especially if you're trying to figure out is it inside, what's not inside. Because I think on the homework they had some that was log of 0.6 plus 1. If you're not used to saying, okay, because there's not parentheses, the plus 1's technically outside, I think that's too confusing, and just, I'm going to put parentheses around it. But last but not least, we need to do what? Divide both sides by 3. So as we have log base 5 of 275 minus 7 divided by 3. And now it's just typing it all into the calculator. I believe you should get negative 1.170. Do you agree with that? And that's all we have to do for these here. So it's not so much that we're learning a whole new process, it's more, the only real new thing we were doing is applying log base 5 or log with the base so that we can simplify it down. Any questions on these here? Do we feel comfortable with these here? Yes. We'll move on. This one here is not any real different than the ones we just did. It's just bigger numbers. So let's look at this one here. This one here is a little bit different because the base is, well, it's not that it's not a number, and I was saying that earlier. Because technically E is a number. It's an irrational number. It's a non-repeating, non-terminating decimal. But if we're wanting to solve this, we really need to get e to the negative 0.3x by itself before we can apply what kind of log to it. It'd be log base what? Or would we even use logs? We'd use natural log. Because the natural log's base is e. So if we apply the natural log to e, it will become 1, and we just have whatever is left over in the exponent. So looking at this here, what can we do first? We can add 7. We would add 7 first, and then we would divide by 4, because we're trying to get e by itself. And 20 divided by 4 would be 5. Any questions on this so far? Now, as we just said, the natural log's base is e, so we're going to take ln of both sides. And really what we're doing is we'll move the exponent out front, and the natural log of e is 1. I found it as an interesting way to remember it, because if the L kind of looks like a 0, we have O-N E, 1. The natural log of E is 1, which just really leaves us the exponent of negative 0.3x is equal to the natural log of 5. Well, we're almost done. What do we need to do? Divide both sides by negative 0.3, which tells me x is the natural log of 5 divided by negative 0.3. And again, at this point here, we just need to type it in. And luckily, with natural logs, we don't have a base to deal with because it's understood to be e. So if we're using natural logs, it's just going to be ln of 5. What did you get? And that's it. That's all we have to do for these here. Any questions on any of these here? We good with this one here? So we have 1, 2, 3 of these e's left. Do we want to look at number 3, or I think it's number 4, the next one after it? Which one do you think would look harder to solve? Or so this 3 or the other 3? Do we want the one with the subtract 4 or the one without the subtract 4? Do this one here. So when we look at this one here, is the base with x, because e to the 4x minus 3, is it by itself? Well, yeah, there's nothing being added or subtracted to it, because the only subtraction that we do have is in the exponent, so we don't worry about that now. But since e is by itself, we can go on and apply natural log to both sides, because I don't want anything multiplied by e, and I don't want anything being added to it. We don't exclude, well, we're excluding what's in the exponent of e, because what's inside the exponent really, for any of these here, is going to move to the front, and the natural log of e is 1. So really what we're left over with is 4x minus 3. Now on the other side, we have the natural log of 19. Now we just need to solve for the value of x. So what can we do first? We can add 3 to both sides. Because negative 3 plus 3 is going to give me 0. So that 4x is equal to the natural log of 19 plus 3. And then we would divide both sides by 4, which tells me x is equal to the natural log of 19 plus 3 divided by 4, which is approximately 'We all agree. And that's it. That's all we have to do with these here. Any questions on any of these here thus far? We feel good with these here? All right. Now, before I make this next statement, I want to see, because I'm going to make a statement with how the book actually does this, because I believe the way that we're going to do this is going to be different than the way the book does this, or tells you to do this. Is I feel like the book is going to tell you to, okay, now we're in agreement. Because one way that we can do this is use our properties of logarithms. Because when we talked about it, log base b of x is equal to y, and we can rewrite it as b to the y is equal to x, and using that kind of switch property. And for a while, I actually taught it that way. That's the way we did it. But there is a little bit better way to do this. And it's using the properties of logs, just kind of like how we did on the last one. Log base 5 of 5 to the x is just x, because the base and the number inside match up. We can simplify the log. But here we already have the logarithm, so we can't quite do that. But we would do what? We would put both sides to the base of 2. Because it works out, 2 to the log base 2 will simplify. This here will simplify out and just leave us with 5x minus 17 is equal to, wait a minute, we have 2 to the third, yes? Is that a nice number? Because what is 2 to the third? 8. Because if we do get nice numbers, might as well just simplify it. Because if we leave it as 2 to the third, anything else we do to it, we can't just combine it. So if we get a number that works out nicely, go on and simplify it. We didn't simplify the logs because, well, log of anything is not a nice number. It has a nasty decimal. So we left it as a log until the very end, where we have the decimal come into play. But here, 2 to the third is 8. 8's a nice number. There is no decimal. So we'll simplify it. Because now when we solve for x, well, we would add 17 to both sides. Well, negative 17 plus 17 is 0, leaves us with 5x is equal to, well, 8 plus 17 is 25. Still, we have nice numbers. And last but not least, we would do what? Divide both sides by 5, which tells us x is equal to 5. Any questions on this here? Now, if we hadn't simplified it to 8, we would end up having to leave, because I can't do just add 2 to the third and 17. We'd have to actually plug something like this into the calculator. Well, that's more complicated than it needs to be, because 2 to the third is just 8. We can do 8 and 17 and divide by 5. So this here isn't necessary. Any questions on any of this here? All right. So what would we do for this here? Three in front of the log, 3 in front of the 4. Or give both of these sides a base of 3. Essentially, we're putting log base 3 of 10x minus 9 into the exponent with 3 as the base. We're putting 4 into the exponent with 3 as the base. And the reason we're doing this is because 3 to the log base 3 will simplify out, leaving us with 10x minus 9. So that'll simplify out completely, and we just have what's inside the parentheses. Now on the other side, we have 3 to the 4th. And 3 to the 4th would be 81. Because 3 times 3, 3 squared is 9. 9 times 9 is 81. Now what can we do next? Add 9 to both sides, which tells us 10x is equal to 90. And then divide both sides by 10, which tells us x is equal to 9. Any questions on any of this here so far? Do you feel comfortable with this here? Not too bad. All right. If we feel comfortable with this here, let's look at this one here. Now, unfortunately, fortunately, we do deal with base 10 here because these are common logs, and since the base is not written, it's understood to be 10. So the base for both of these logs is 10. I can't just apply it to both sides at this point here because of this addition. It wouldn't apply to both. It would apply to the entire log of 2x plus log of x minus 5. So it'd be nice if I could condense those two logs into one. And we actually do have a way of doing this. Because our multiplication property of logs stated that log base b of m times n is the same as log base b of m plus log base b of n. So that means for this here that we can rewrite log of 2x plus log of x minus 5 as log of 2x times x minus 5 is equal to 2. So any questions on kind of how we got this to this 1 log? And this is going to be useful. That's why we did that whole part of condensing logs and expanding, getting used to those properties of how we can put them together and pull them back apart. Now for this here, we can apply the 10 to both sides. Because 10 to the log base 10, it's not written as 10, but the base and the base do match up here. And since they match up here, they will simplify out, leaving us with just 2x times x minus 5 is equal to, well, 10 squared is 100. What would we need to do next? Yep, we're going to have to distribute the 2x. Well, 2x times x is 2x squared. 2x times negative 5 would be negative 10x is equal to 100. Well, we have a quadratic. Because of our x squared term, we know that this would be a quadratic. So that means we've got to get everything on the same side. So we can do that by subtracting 100 from both sides. These will cancel out, telling me that I have 2x squared minus 10x minus 100 is equal to 0. And so we're going to go on and solve from here. Is there a greatest common factor between these 3 terms? 2, yes. 2x squared, 10x, negative 10x, and negative 100 all divisible by 2, yes? I'm going to divide this by 2, divide both sides, essentially divide the whole thing by 2. Well, 2x squared divided by 2 would be x squared. Negative 10 divided by 2 is negative 5x. And 100 divided by 2 is 50, and 0 divided by 2 is 0. Now, what we're doing is we're dividing the whole thing by a scalar. That 2 is just a scalar. It's scaled everything up by a factor of 2. Now, if this had been a variable, if they all had, it was x cubed, x squared, and x, we'd have to actually factor it out and leave it out front. Because when I divide by a variable, I'm moving a solution, I'm pulling a solution out of the equation, which could work as an actual solution, but since we removed it, we won't actually get it in the end. Does that make sense, the difference between those two there? So in any time we're solving higher degree polynomials, we can divide everything by a constant term, a number, to reduce the terms. If you're trying to factor 2x squared minus 10x minus 100 is possible, we could do it, but it's a little bit harder to work with because now instead of just x squared, we have 2x and x. This one here is a little bit easier to work with because our factors of x squared are going to be x and x. Our signs are going to be positive and negative because the 50 is negative. Our third term is negative. And now we just need to figure out the factors of 50 that will work together to give us 5. Well, we can have 1 and 50, 2 and 25, 5 and 10. And which one's positive and which one's negative? And the 10 is negative. And the last part of this is we need to set both of these equal to 0 because of our zero product property. Any two things multiplied together to equal 0 means one of them has to be 0. So on the first one, we can subtract 5 from both sides, which tells us x is equal to -5. And on the second one, we can add 10 to both sides, which is tell us x is equal to 10. So any questions on any of this here? One of these two solutions won't work. Because I talked about this yesterday. What did we say we cannot have inside of a logarithm? A negative. Now, just because x is equal to -5 doesn't mean it won't work. It won't work here. But it's not always going to be the case. Just because x is negative means it's not going to work. What we have to do is plug it back in to check it. So when we start off, it'd be log of 2 times -5 plus log of -5 minus 5 equals 2. Well, 2 times -5 is -10. Well, I have a negative inside of the log. So I know immediately that -5 doesn't work. Even if we kept going, I have another negative inside the log. So it doesn't work for the original problem. If it had started out as log of 2x times x minus 5, our first main step of putting those together, then it would work because, well, -10 times -10 is positive 100. But we can't have this negative inside of the log, so it doesn't work. And if we check 10, well, log of 2 times 10 plus log of 10 minus 5 equals 2. Well, 2 times 10 is going to be 20 plus log of 5. And it does work out that 2 is equal to 2. So I see here x is equal to 10 is our solution. X is equal to -5 is one of our extraneous solutions. It is a number or a solution that we do get from solving it, but does not work in the original problem. Any questions on any of this?